Hey, hey, hey man, you shouldn't slouch. It's not good for your posture.
Nah, it's fine. I do it all the time.
Seriously, man, I was looking into it and some of the side effects read decreased mood, decreased concentration, an increase in shoulder and back pain, and it affects your sexual function.
Really?
All jokes aside, good posture is important for a person's health, and as a student, this isn't a surprise to me. Some pieces of evidence that stood out were decreases in mood and an increase in headaches. I've noticed now more than ever after being home more often. COVID! After a long day of class and studying, while taking constant breaks, I've noticed I've needed to postpone work because of my discomfort from my sitting position. Studying is already difficult. Why should we make it more difficult for ourselves when there's an easy solution? I wanted to create a device that was relatively easy to make, one that other engineering students could use if it was of their interest. I believe that if a person betters their posture through their habits, then they are one step closer to completing their tasks on time. And with that reminder, it will be a lot easier to maintain a better posture. The way I planned on bringing this idea to life was by using a 3-axis accelerometer and by attaching it to the back of my office chair. Here are some graphical images in 3 dimension that describe how the accelerometer is affected in the z-axis. The z component is measuring the acceleration of gravity, and when there's a change in that acceleration, the accelerometer records it. From my understanding of physics, whenever I don't slouch, the z component should decrease, as the normal force holding the chair up is now dispersed into 2 components rather than one. I will be able to monitor this z component and make sure it doesn't dip below a certain standard that I deem appropriate. The same thing happens in the y component, on my left and on my right sides of the chair. And I record those values and test them against another threshold as well.
So, let's take a look at the code I used to design my device. For the sake of time, I'm going to skip over the parts I don't feel require much of an explanation. With that being said, you can pause the video and take a look at the program if you need to. I started by creating an array to store the output for my accelerometer. This allowed me to store the z and y values in a common place, which I later used to index through and take the average of the outputs from my accelerometer. The infinite while loop you can see on line 14 encompasses my whole function and infinitely checks and stores output values from the accelerometer. Lines 15 to 23 are parameters I had to set to assign values, and you can take a look at those if you have a chance. Line 29 to 32 are the lines that stop my program completely when I press my button connected on my Arduino. Lines 35 and 37 average out the values in my array that were initialized previously, so the values that I test against my threshold are more accurate. Finally, lines 41 through 90 check my second standard, then execute the rest of the code. On lines 47 and 48, my program waits 5 seconds and takes the accelerometer outputs again to further reduce errors and random movement I make in my chair. It would be very inconvenient to shift in my chair and hear a beeping sound. After this section, the average of the y and z values are taken again, and if it meets both criteria, the program will tell the Arduino buzzer to beep, repeatedly checking the code until there's a change in acceleration. First, let's make sure everything's running smoothly. I wrote a function that tracks all of the outputs from the accelerometer and displays them in my command window. The z component is the second column and the y component is the first column. I will start by moving the z component, the second column independent of y, and then vice versa. You should see both components change when I rotate the accelerometer in 360 degrees. This should show the endpoints being around 9.8 and negative 9.8 for both components. Second, the graph. I graph both the z component and the y component when both motions are independent of each other, and we get a shape that resembles the xy axis. This demonstrates the motions are indeed independent of each other. Now we can get started on testing my posture sensor.
Here's the demonstration of my posture sensor. I'm leaning back in a comfortable position and the Arduino is on, as you can see by the flashing communicating lights. Now I'm going to lean forward for a period of 5 seconds and the buzzer shall go off. It will do this until I lean back into the chair where it stops, and we will see when I do that now. As you can see, the Arduino is no longer beeping, but it is still running. If I were to get up from the chair again, it will test the same 5-second interval to see if I am still in the chair. And again. Comes to a stop. So we check slouching. Let's check leaning to my left or right side. Now we can see that the Arduino is on still by the flashing lights. Now if I were to lean to the left while doing my work, the Arduino should beep until I go back into the position originally. Let's try again. Wait, test that 5-second interval as well. And it will keep doing this until I go back into my chair. To halt the function, we can press the button right over here, and we should see the communicating lights stop now.